Hello everyone, welcome to my channel. Today I'm going to share you how to check for the PCB board. This PCB board, the one JCB used it for JCB JS220 excavator engine ECM. So this PCB board is something wrong. Engine cannot be started. So today I'm going to share you how to diagnose the problem and what is the PCB board operation and other related circuit by practically and theoretically. So this video will be a little longer than my previous video because this is the circuit. This PCB cannot work only one. So this PCB board working combination, working together with voltage converter and emergency stop relay and PCB board. And after that, send to the engine ECM. So if this PCB board is something wrong or fault, engine cannot be started. So look at this. This is the inside construction of the PCB board. Cover here. We can see the position of the relay and fuse, power hole relay, ignition relay, voltage dropper relay 2, high ampere fuse, 10 ampere fuse, 10 ampere fuse, and the lower side pure lip pump relay and gray heater relay. Okay, first of all, please remember there is two types of relay. This PCB board uses two types of relay, 24 volt and 12 volt system. 24 volt relay and 12 volt relay. Power relay is this one, the 12 volt relay, ignition 6 relay 24 volt, voltage dropper relay 24 volt and voltage dropper relay 2 12 volt. The lower side pure lip pump relay 12 volt and gray heater relay is 12 volt. Okay, so if we put the wrong relay, this voltage converter cannot be worked. So now let's look at the electrical diagram again. Emergency stop relay, voltage converter, fuse, main relay, PCB board, engine ECM. So the rear part is voltage converter. This one is on the voltage converter. PCB board, engine ECM. Okay, emergency stop relay. I don't have it here. It's okay, no problem. Okay, so look inside for the PCB board. There is a two relay, voltage dropper relay 1, 24 volt system, voltage dropper relay 2, 12 volt system. Look at voltage dropper relay 1, this one, 24 volt, voltage dropper relay 2, 12 volt. And after that, power hole relay, ignition 6 relay 24 volt, power hole relay 12 volt, ignition 6 relay 24 volt. And then pure lip pump relay 12 volt, gray heater relay 12 volt. Pure lip pump relay 12 volt and gray heater relay 12 volt. So this PCB board operation is there are 3 parts: part 1, part 2, and part 3. So let's say like that, because these 2 Buddhist dropper relay are working as first time, and power hold relay 12 and ignition switch relay work as say second time, second operation. The final operation is fuel lead pump and gray heater relay. Gray heater relay is extra. It's like an option, no use. So we don't need to think about what this gray heater relay is working or not for this machine, this model, because now we are learning for the JCB JS220 excavator. So we have to okay, so we have to continue for the fuel lead pump relay. Fuel lead pump relay is part 3. This one there, part 3 operation. Okay, so this one the rear construction, and so X the electrical schematic and system operation. Buddhist dropper relay 1 and Buddhist dropper relay 2. Power supply is come from the line 1. Line 1 is from 30 ampere relay. After main relay on, before the key switch on, 30 pin number 30 and pin number 30 is standby power supply waiting here. And the second operation is from the key, after the key switch on. So emergency relay, key switch. When the key switch on, power come from the line 2 and pass the number 5 ampere fuse. Number 5 ampere fuse. This one number 5 ampere fuse. Okay, 5 ampere fuse. And then Buddhist dropper relay pin number 86. Ignition 6 relay pin number 86. Buddhist dropper relay. This one the pin number 86, and Buddhist dropper ignition 6 relay pin number 86. Buddhist dropper relay, this one pin number 86 and pin number 86, and ignition 6 relay. This one ignition 6 relay pin number 86. Pin number 86 is power supply. 85 should be ground. Okay, let's go ahead. Okay, here. Okay, here. Okay, on the other side. We have to say the I have to explain for the complete circuit, because for the line 1, from the line 1 is 24 volt waiting here. So the power already here at the pin number 30, and 86 already power here 24 volt. So on the other hand, we need the ground circuit to operate for this relay. So at the Buddhist dropper relay, pin number 85 is ground. Here, ground. Number D, pin number D is ground. This one pin number D. See, pin number D is ground. Okay. So when the pin number D ground, and ignition 6 relay here, ignition 6 relay 86, 85 is ground. Okay, so from the line 1, when the key switch is on, Buddhist dropper relay is operate. Buddhist dropper relay operate, and this Buddhist dropper relay 2 operate. Power from the 30 is sent to the Buddhist dropper pin number 1 and 2. Pin number 1 and 2. So when this 2 relay on, when this 2 relay on, the power is sent to the Buddhist converter. This Buddhist converter. After that, the Buddhist converter produce the 12 volt here. Can you read? Treble, pin number 4 and pin number 5. Here. Come to here and produce. And this one the treble, pin number 30 and pin number 86. This one the treble, power hole relay. Power hole relay. This one power hole relay. This one, this really power hole relay. Okay. So here, power hole relay is ground by the ECM. So when this power hole relay, one is from the Buddhist converter, ground wire is from the ECU ground. So when the disc relay on, treble Buddhist from the Buddhist converter are continue to send for the engine ECM. All of the pew, this pew. So after this power hole relay on, the power we have here. These are all the treble. Okay, look at this ECM pin, engine ECM pin number 49, come from PCB box pin number N, P, R, and 5, S, and pure ribbon relay. This one the 86 and 30. Pure ribbon relay also the ground, ECM ground. So when the pure ribbon relay on, the treble power supply is sent to the pure ribbon relay. Okay. Grid heater relay is option right there. So when the pure ribbon relay, this one is on, the pure ribbon will have the power, and then pure ribbon will be working. Do you understand what I mean? Okay, so like that. Okay, so after explanation for the electrical schematic, so we will practically check for this Buddhist converter. So I have to connect the wire because this PCB bulb need the power supply for test. So here I have the Buddhist converter, one end. I have the some wire fabrication. Okay, like that. Yeah. In here, this on the Buddhist PCB bulb. PCB bulb have the pin number A and B, 24 volt at the PCB bulb. You can see here the B and A is from the battery plugs 24 volt. So this one the shortcut. This one the electrical schematic. So I will connect the pin number A and B. This one from the battery plus. Okay, and another one. This one pin number MHKD PCB bulb, and here MHTK MHD. Sorry, MHDK. Yeah. MHTK at the PCB. You can also read the number here. MHTK PCB. This one the ground. This one we have to connect the battery negative. So right now I didn't connect yet. Okay. This one for the PCB bulb, and at the Buddhist converter, pin number 3 and 6. Pin number 3 and Pin number 6. This one the ground. Here the pin number 6 and pin number 3. This one the ground. So I put all together for the ground. And next connection is here at the PCB ball J, at the PCB ball pin number J, pin number J, here this one J, this J connect to the boost converter pin number 5, 12 volt. Okay, boost converter pin number 5, this one PCB ball J. Okay, and another one is boost converter pin number 2 and PCB ball number F. So pin number F and boost converter pin number 2, PCB ball pin number F and boost converter pin number 2. So this one already complete, and this one the extra. So we don't need to think about this one, just leave it. So right now I already connect all of the necessary power supply and ground. Then I can test it. Okay, like that. So I will connect the negative cable. Okay, you can hear the click sound. So now it's already working. So continue to check for the voltage. Okay, like that. Multimeter. Put the multimeter here. And ground circuit, ground wire here, and test the power of the circuit. So now all fuse have the power right now. Okay. Can you read it? I think you cannot read it. Okay. So I put the multimeter at the voltage and some the test lead for the negative, and I start to check it. This one the 24 volt. This so there is a power. This fuse must have the power even this power whole relay and ignition switch relay even not working. Before working, this power whole relay and ignition switch relay, because this power is directly come from the fuse, main fuse. So we have to think about all of these fuse are working after this power whole relay and ignition switch relay. Sometimes this boost converter is for this power whole relay and ignition switch relay will not be working, and then there's no power. There is no power supply. There is no power for all of this fuse here. Also the pure lead band relay, no power, and pure lead band will not be work. Then engine won't be start because there's no power supply for the engine ECU, engine ECM. Okay. So right now I'm putting the good Buddhist converter. This is the brand new one. So I have the other one. This is the faulty one. So I will say and text how is the condition is it. You can also look at. Okay. So first of all, I will remove it. Okay, after we test by the good Buddhist converter, we continue to test by the 40 Buddhist converter. Okay, so all of the connection already connect, negative cable already connect, and then check the Buddhist 5 ampere fuse. Here 25 volt. It's normal. 25 volt. 25 volt normal. Okay. So check the other fuse. No Buddhist. No Buddhist. Check. No. Check. No Buddhist. Okay. Check. No. Check. No Buddhist. No Buddhist. No Buddhist. No Buddhist. Okay. So only have the power in here. So that means power already here from the key switch, but this PCB board is not working because of this power hold relay, ignition switch relay are not working. So there's no power supply for this fuse because this Buddhist converter not supplying the 12 volt system. Okay, so let's look at the electrical schematic here. 25 amp. 25. This one the 5 ampere fuse. 5 ampere fuse here. This one come from the key switch. The power supply already in here, but there's no power supply for the power hold relay and ignition switch relay. Because power hold relay here, the 12 volt come from the Buddhist converter. Power hold relay is working 12 volt system, and ignition switch relay here 12 volt system. So ignition switch relay and power hold relay are not working right now. So that's why there's no power. So this power is sent to the ECU and also for the pure lead band. So right now we can identify how to check this PCB board and also related to the Buddhist converter. So I suppose this video will have you how to check the PCB board and Buddhist converter because these are related circuit. So thank you so much for watching my video. So hopefully this video will have you when you have problem with the engine cannot start problem on the JCB JS220 excavator. Okay, so thank you so much. So we will see you again in the next video.